In this lesson, we're going to learn how to make ionic compounds. The first thing I need you to do is have these two pieces of paper cut out and glued onto the top of page 83 and title it How to Make Ionic Compounds, and that you have a least common multiple method and then a crisscross method. That's the first thing to do. We're going to talk about both of these. These are methods for making ionic compounds. Let's first talk about the one that makes students more comfortable, which is the crisscross method. So let's talk about this one first. All right, this one is the crisscross method. The directions are right here. It says the digit of the charge becomes the subscript for the other ion. I would like you to highlight that. The digit of the charge becomes the subscript for the other ion. So it says the digit of the charge becomes the subscript for the other ion. Those are the important words. A subscript, for example, if I have this ionic compound, this 2 is the subscript. Let's take a look at our example. The digit of the charge. The digit of the charge. So here on the lead ion, it has the digit is a 4. Right? This is the digit of the charge. If you take a look, it has an arrow going over here, right, to the other ion, and the 4 right there is the subscript for the other ion. So the digit of the charge, the 4 of the lead, Pb, became the subscript for the O, because it's the other ion. Let's take a look at O. The digit is 2 for the charge, just the digit, and they have an arrow going over here, and you notice that the 2 is now the subscript for lead. This is the crisscross method. Let's talk about why. Why are we doing this? All right, so the why is sorry. Okay. Ionic compounds have an overall charge, or they're neutral for an overall charge. Another way to say that is that the ion add to 0. Ion charges. Right? So ionic compounds have an overall charge that is neutral, which means that the ions add up to 0 if you're going to add them together. So we're going to do that right now. We're going to take a look at this formula right here. And it's telling me that I have 2 of the lead ions. So I have Pb4+, and I have a second one because it tells me I have 2 of them. That's what's there. I also have 4 O2 minuses. So I have O2 minus. I have 4 of these. If I add up what the overall charge would be, I'm going to get here 8 positive. And if I add up what the overall charge would be here, I'm going to have 8 negative. If I add positive 8 plus a negative 8, I'm going to get 0. So that means the overall charge of this, which is an ionic compound, is 0. Your formulas have to add up to no charge. Right? That is the first method. Here's the second one. It's not as comfortable until you really understand the concept. Now I have these two ions right here, and one of them has a 3 plus charge and the other one has a 2 minus charge. This right here has to have no charge, so we need to have no charge here. So whatever is going on with these ions, they have to add up to 0. When I take a look at these two and figure out how to get them to be the same total quantity of charge, I can think about it with the least common multiple. Both of these numbers, the least common multiple would be 6. So I'm identifying the least common multiple. I have a definition down here if you don't remember what that is. Then I identify the number each charge would be multiplied by to make the least common multiple. So here's my 3. The 3 plus from the charge. I'm multiplying that by 2 to get the 6. The number identified in step 2 is the subscript. So take a look there, there's the 2. Same thing over here, I have a 2 minus. I need to multiply it by something to get the least common multiple. So that would be 3, and the charge there is 3. I mean, the subscript is 3. This one works also. So if you look at this, I think, oh, well, they both go into 6. What do I multiply by 3 to get 6? 2. So I need 2 of these. And what do I multiply 2 by to get 6? So I need 3 of them. So we're going to take a look at something that looks like this. For this example, get any paper. Right? So again, the overall charge has to be 0. Here you go. Here this tells me I have Al, and it has a 3 plus charge, and I have 2 of them. So Al plus Al. The total of those charges is 6 positive charges. This tells me I have 3 O2 minuses, so here the 3 are. And the overall of that charge is 6 minus. If I take 6 plus and I add on the minus 6, I'm going to get no charge, 0. So that means that that one works out also. So this is how to use these two resources to make ionic compounds.